Hello everyone, welcome back. Today we'll continue the 7th chapter in the book that talks about public, private, scoping, module, design, etc. Previously we stopped with the restaurant example. I'll open it. Yeah, so let's jump into it. Bringing path into scope with the use keyword. Having to write out the paths to call functions can feel inconvenient and repetitive. In listing 7.7, wherever we chose the absolute or relative path to the add to waitlist, I'm talking about this function, every time we wanted to call add to waitlist, we had to specify front of house and hosting too. Fortunately, there's a way to simplify this process. We can create a shortcut to a path with the use keyword once, and then use the shorter name everywhere else in this scope. Okay, so it's based on scope. In listing 7.11, we bring the create front of house hosting module into the scope of the eat at restaurant function. So we only have to specify hosting add to waitlist to call the add to waitlist function at eat at restaurant. Okay. What we did here is inside, okay, where's the eat at restaurant here? Eat at restaurant, so I'm doing this, I'm doing use, create front of house hosting, and then basically I can just delete this, and this should work. And if I navigate here, yeah, it finds this function. Okay, great. Adding use and a path in a scope is similar to creating a symbolic link in the file system. By adding use create front of house hosting in the create root, hosting is now a valid name in that scope, just as though the hosting module has been defined in a create root. Paths brought into scope with use also check privacy, like any other path. Let's just remove what we're doing. Front of house. So we have back of house. We have front of house here, and if I remove the public identifier from here, okay, I'm getting an error here. Okay, so basically instead of having errors here where we had the long list, now we're getting the error here, and if I save it, we're getting everything back. Great. Okay. Note that use only creates the shortcut for the particular scope in which the use occurs. Listing 7.12 moved the eat at restaurant function into a new child module named customer, which is then a different scope than the use statement, so the function body won't compile. So we have a new module named customer. And we move the function eat at restaurant inside this. And now we have to move the use here. And we don't have this. So back of house is not in scope. So we have to do create back of house, right? Or we can use super back of house, and self will not work because self is already the customer module. So let's put the create here. Okay, the compile error shows that the shortcut no longer applies within the customer module. What? This shortcut. Okay, so if I move this here, I'm getting an error because this is not defined. So the use is only for the scope, not even for a subscope. We need to remember that. And it's a good thing, because when we use the use keyword, it can create some conflicts with things defined within other code or within our own code. So this is good that the use is only valid for the specific context. Okay, notice there's also a warning that the use is no longer used in this scope. To fix this problem, move the use within the customer module 2 or reference the shortcut in the parent module with super hosting within the child customer module. Okay, so I can, instead of using this, now I have this, and I can do this. Right? Yeah, now it's just yellow and no errors. Now it's an error. So let's put it back in. Okay. Creating idiomatic use paths. In listing 711, you might have wondered why we specified use create front of house hosting and then called hosting add to waitlist. In Eat at Restaurant, rather than specifying the use path all the way out to the add to waitlist function to achieve the same result in listing 713. Okay, so we can use this. Okay, although both listing 711 and 713 accomplish the same task, listing 711 is the idiomatic way to bring a function into scope with use. Bringing the function's parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined while still minimizing repetition of the full path. The code in listing 713 is unclear as to where add to waitlist is defined. On the other hand, when bringing in structs, enums, and other items with use, it's idiomatic to specify the full path. Listing 714 shows the idiomatic way to bring the standard library hash map struct into the scope of a binary crate. Okay, so let's discuss. So we can, if we want, we can use this, like add to waitlist, and then we can use it like this. What they're saying is it's not like the correct way to use it because now we don't know where waitlist came from. But because of the hints in the IDE, I don't see the big problem here. And also I can navigate to this function if I want. Yeah, the IDE provides some tools that make this a non-issue. But I guess if they really want to do this, then at least for now we're doing this. And of course, they're saying when we're including enums and structs and enums and structs, we can go all the way and use the final function or object that we want. Well, not function, object or enum that we want, as they show here in the hash map example. Okay. There is no strong reason behind this idiom. It's just the convention that has emerged, and folks have gotten used to reading and writing Rust code this way. The exception to this idiom is if we're bringing two items with the same name into scope with use statements, because Rust doesn't allow that. Listing 715 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. So I have standard format, standard IO, and this is the way. Okay, so if I'm trying to bring an enum or a struct, and they have the same name, so I have to revert to using the longer way of doing this. Yeah, that makes sense. I don't think someone will be confused by that. Yeah. So let's continue. As you can see, using the parent module distinguishes the two result types. If instead we specified use standard format result and use standard IO result, we'd have two result types in the same scope, and Rust wouldn't know which one we meant when we used result. Makes sense? Yeah. Okay. Providing new names with the S keyword. Okay, I've been waiting for this. There's another solution to the problem of bringing two types of the same name into the same scope with use. After the path, we can specify as and a new local name or alias for the type. Listing 716 shows another way to write the code in listing 715 by renaming one of the two result types using as. Okay, so I can use this and then rename it to a different thing. My approach with this is to rename everything that collides, because it prevents errors, prevents misunderstandings. Yeah, because if I see result and I don't have the hint, then I don't know which type of result we need. I would done something like this. Like if I'm using this code and I go here, right? So I would have done it like this. Yeah, and then put this like this, and there's an error. Because I'm not returning. Okay, but you get my intention. If I have something that collides, or even collides possibly, I'd like to have a more distinct name that reflects the type. Okay, let's continue. In the second use statement, we chose the new name IO result for the IO result type, which won't conflict with the result from the format. And then we've also brought into scope, listing 715 and listing 716 are considered idiomatic, so the choice is up to you. Okay. Re-exporting names with the pub use. When we bring a name into scope, with the use keyword, the name available in the scope is private. To enable the code that calls out that calls our code to refer to that name as if it had been defined in that code scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope, but also making that item available for others to bring into their scope. Listing 717 shows the code on listing 711 with use in the root module changed to pub use. Okay, so we have pub use. Okay, so wait, I'm doing this, I'm getting an error. If I have pub use, it's still an error. Because eat at restaurant should be here. Okay, let's read on and see what they mean. Maybe they mean that if I'm doing this, then I can actually do this, and this should work. Or I need to do like this. Oh, sorry. Oh, this works, and if I remove the pub, then it stopped working. Okay, got it. So basically, I can make this public. If I'm declaring this as public, then anyone can call this use from within the customer module. Okay, so let's read the explanation. Before this change, external code would have to call the add to waitlist function by using the path, this long path. Now that the pub use has re-exported the hosting module from the root module, external code can now use the path restaurant hosting. Wait, is this? Restaurant is the module. Hosting add to waitlist. Okay, because I'm exporting this here in the module. And as you recall, the module is called restaurant. It's right here. Okay, before this, re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house. But customers visiting the restaurant probably don't think about the parts of the restaurants in those terms. With pub use, we can write our code with one structure but expose a different structure. Doing so makes our library well organized for programmers to work on the library and programmers calling the library. Yeah, we'll look at another example of pub use and how it affects your create documentation in exporting convenient public API with pub use. I think in chapter 14, I think they're talking about something I'd like to do is in Python, I like to collect every API that I think that the user would like to use in one file and I just import and export it and then the user only have to import one file with all the exports that are relevant to the user. And then it's easier to understand what's the scope and what are the objects that are in this library without digging too much into the source code. Yeah. So I think that's what they're going to talk about in chapter 14. Probably they'll say inside the librs or the main.rs, I'll just have a series of use statements that bring specific types, enums, and functions into the create scope, basically for users to use without going to the length of using these types of statements, like statements this long. Okay, using external packages. I think in chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers. To use rand in our project, we added this line to the cargo toml. Yeah. Adding rand as a dependency in cargo toml tells cargo to download the rand package and any dependencies from crates.io and make rand available to our project. I guess crates.io is like the npm repository or any other like pipe I think repository for pip. Yeah. Okay, where we were, great. Yeah. Then to bring rand definitions into the scope of our package, we added a use line starting with the name of the crate, rand, and listed the items we wanted to bring into scope. Recall that the generating a random number section in chapter 2, we brought the RNG trait into scope and called the rand red RNG function. Yeah, I remember wondering why can't I do it all in one go, but okay. Members of the Rust community have made many packages available at crates.io, and pulling any of them into your package involves the same steps: listing them in your package's cargo toml file and using use to bring items from their crates into scope. Note that the standard library is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo toml to include std. But we do need to refer to it with use to bring items from there into our package's scope. For example, with a hash map, we would use something like this. Not collection hash map. I think collections is the next chapter. I'm not sure. This is an absolute path starting with std and the name of the standard library crate. Okay. Using nested paths to clean up large use lists. If we're using multiple items defined in the same crate or same module, listing each item on its own line can take up a lot of vertical space in our files. For example, these two use statements we had in the guessing game and listing 2.4 bring items from std into scope. Okay. Instead, we can use nested paths to bring the same items into scope in one line. We do this by specifying the common part of the path, followed by 2 colons and then curly brackets around the list of parts of the path that differ, as shown in listing 718. I don't care for this. Yeah, it allows for more order, but come on, I don't think that you read the includes that much, especially in languages with a lot of like outside packages that yeah, well, it's nice. It's nice for making the code look cleaner, but nicer. In a big programs, bringing many items to scope from the same crate or module using nested paths can reduce the number of separate use statements needed by a lot. We can use a nested path at any level in the path, which is useful when combining 2 use statements that share a subpath. For example, listing 719 shows 2 use statements, one that brings std.io into scope and the other that brings std.io right. So I guess, oh yeah, and we can use the self keyword here. The common part of these 2 paths is std.io, and that's the complete first path. To merge these paths into one use statement, we can use the self in the nested path as shown in listing 720. Okay, we can do this. Again, it's really nice for including stuff. I like to have includes in a way that I can see. I prefer to put includes at the end for languages that scan the entire file and don't depend on the order. but I think that there's like automatic tools here that always push the use upwards. Let me just see if I'm using this, if this will work, just to see. Yeah, this works. So depends on, like, when we write the first significant project, we'll see if I like to put the uses at the bottom of the file or at the top of the file. Okay, the glob parameter. If you want to bring all public items defined in a path into scope, I never want to do this. We can specify that path followed by the asterisk glob operator, like this. The use statement brings all public items defined in the collection into correct scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and where a name used in your program was defined. The glob operator is often used when testing to bring everything under test into the tests module. We'll talk about that in how to write test section in chapter 11. Yeah, exactly. Never use it. Like it just confuses people, and confuses when you write code. You have to, like, if you write, if you did this and you have a result somewhere here, like we saw here, like, and then you want to include a result. Now there is a conflict even without you implicitly using two result items. This one, yeah, I would never use this if I could. Like, yeah, okay, let's move to the next part. Okay, separating modules into different files. Oh, finally, I think now we had only one file here. Yeah. Okay, so far all the examples in the chapter define multiple modules in one file. Okay, we had something at the beginning that had several files. When modules get large, you might want to move their definition to a separate file to make the other code easier to navigate. For example, let's start from the code on listing 717 that had multiple restaurant modules. We'll extract modules into files instead of having all the modules defined in the create root file. In this case, the create root file is src librs, but this procedure also works with binary crates with the main rs. First, let's extract the front of house module to its own file. Remove the code inside the curly brackets for the front of house module, leaving only this declaration so that srclib contains the code shown below. And listing 721. Note that this won't compile until we create this file. So let's first create the file. New file. It's called front of house.rs. Right, and now we'll take all the front of house that we have here. We cut and we paste. Let's see that it compiles. We have something that depends on front of house here, and this is the use. Okay, so the use depends on it, and we can go. Let's just follow the link to here, and it brings us to the front of house file. Looks like it works. Okay, so now it tells us to place the code there in a new file, and it's public, right? We defined everything public, and serving is not public. So if I try calling serving here, if I go, wait, let's be inside a function. If I go front, no, I need to do create front of house and serving. I see there's no autocomplete, and if I do serving here, it'll say, well, let's see what function, take order. If I do serving take order here, then probably the serving will be red. No, I need a semicolon, and the serving is red because it's not available. But if I'm doing this, it will still be an error, but not in serving in a take order, because now take order is private, and now I'm making it public, and now it works. Excellent. Okay, note that you only need to load a file using a mod declaration once in your module tree. Once the compiler knows the file is a part of the project and knows where the module tree, the code resides because of where you put the mod statement, the other files in your project should refer to the loaded file code using a path to where it was declared, as covered in paths for referring to item in the model tree section. In other words, mod is not an include operation that you may have seen in other programming languages. Okay. We'll see like how it works. I didn't completely understand the ramifications. That means that I need to only do the mod once and I can use it. Let's say you do something like this. Let's say I'm doing here a new file back of house, right? And then I'm putting back of house here. Right. And now let's say I want to use something from front of house here. Yeah, let's say in summer I want to use, let's say, crate front of yeah, so front of house is already here. Yeah, so I defined in the crate here the front of house, and this already knows. I can also use the thing super to get this, right? Yeah. I can use super in front of house. Wait, if I do this, yeah, I have the customer, front of house, and the deliver order, which are defined in the main library here. Okay. Let's continue reading. Okay. Okay, to start move. Oh, okay. Now we want to move the hosting inside. So we need to create a folder probably. Okay. Next, we'll extract the hosting module to its own file. The process is a bit different because hosting is a child module of front of house. Let's go to front of house. Yeah. Okay. The process is not of the root module. We'll place the file for hosting in a new directory that will be named for its ancestors in the module tree. In this case, front of house. So I'm doing a new folder, front of house. Then here I'm creating a new file that is called hosting rs. Right, and in the hosting rs, I'm just copying these two functions. And here I'm just leaving a semicolon. Okay, so it looks like it's working. Let's go back to the lib. We do have the hosting working correctly. If I go to hosting, I go here. Okay, there is another way from the beginning of the chapter that we can also put mod.rs inside to define this. So let's try this. If I do a new file, mod.rs, mod.rs, and then I copy things from here, this will also work. At least it should work. Yeah, no issues. If I go to hosting, I go here. Great. Okay. If we instead put hosting rs in the source directory, the compiler would expect the hosting rs code to be in the hosting module declared in the crate root and not declared as a child of front of house. Makes sense? The compiler rules for which files to check for which modules code means the directories and files more closely match the module tree. Yeah, that makes sense to make people shape it like this. It's a shame that you can do both mod.rs and using the file. I wish there was just one straightforward way. Okay, alternate file paths. Well, I think it's the thing we're talking about now. So far, we've covered the most idiomatic file path that the Rust compiler uses, but Rust also supports an older style of file path. For a module named front of house declared in the crate root, the compiler will look for the module's code in the rs file, what we covered, and mod.rs, something that we added now. For a module named hosting, that is a submodule of the front of house. the compiler will look for the module code here and here. Yeah, the same. So it's older style and still supported. So this is not a good thing to use, so we'll revert back for this example, and then go to mod, cut, paste, delete. Great, everything still works. If you use both styles for the same module, you'll get a compiler error. That's good. That's actually good. Using a mix of both styles for different modules in the same project is allowed, but it might be confusing for people navigating your project. The main downside of the style that uses files named mod.rs is that your project can end up with many files named mod.rs. Yeah, which can get confusing when you have them open in your editor at the same time. Yeah, makes perfect sense to use the new method. I don't see a reason to use this. We've moved each module's code to a separate file, and the module tree remains the same. The function calls in Eat at Restaurant will work without any modification, even though the definitions live in different files. The technique lets you move modules to new files as they grow in size. Note that the pub use blah 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 statement in srclib also hasn't changed, nor does use have any impact on what files are compiled as part of the crate. The mod keyword declares modules, and Rust looks for a file with the same name as the module for the code that goes into that module. Summary. Rust lets you split a package into multiple crates and create crate into modules that you can refer to items defined in one module for another module. You can do this by specifying absolute or relative paths. These paths can be brought into scope with a use statement, so you can use a shorter path for multiple uses of the item in that scope. Module code is private by default, but you can make definitions except enums. Definitions public by adding the pub keyword. In the next chapter, we'll look at some collection data structures in the standard library that you can use in your newly organized code. Okay. So basically now we have the basic structure of a module. We didn't learn how to package a module. Sorry. I guess we'll do it in future chapters. Yeah, so basically everything is private. You have to declare things that are public. And we learn how to use the use as idiom to bring and organize imports. The file structure also indicative of the module tree inside the crate. Okay, I guess that's it. We'll do the next chapter next time. Thank you very much. See you next